Chapter 10 is all about the biological rhythms. One of the most important and well-known biological rhythms discussed in the chapter is sleep. Today, I will be teaching you about the 4 different phases of sleep. When measured with EEGs, each of these phases reveals what the brain is doing during those phases. As it turns out, sleep is more than just a period of inactivity in the brain. Let's get into it. So before we get to sleeping patterns, first let's talk about what the brain activity looks like when you're awake. Now, there's 2 important things that you need to know about this particular brainwave. The first one is that it's low amplitude. And what I mean by low amplitude, I'm talking about how big the wave is up and down. So, for example, low amplitude waves are small, like this. Whereas an example of a high amplitude wave would look something like this. The second important characteristic of the active brain is that it's high frequency. Now, frequency has to do with how many waves are packed into a certain amount of time. So, for example, high frequency would look something like this, whereas low frequency would look something like this. Now, how frequent exactly? Well, it will be 15 to 20 cycles per second in an active brain. So you imagine here, in one of these cycles, from here to here, it'll be 15 of those in 1 second. This brain activity is referred to as beta activity, or also desynchronized EEGs. Now, in between me explaining each of these waves, I'll be switching over to a piano camera, and hopefully I'll be able to play some scales for you that'll help you to remember exactly what these waves are like. But just remember that for the active brain, because it's awake and alert, it's a lot of really small waves really fast. Hello, welcome to my piano segments where I will be hopefully using music to help you remember what a wave of the brain looks like during the different phases of sleep or versus being awake. Now, for the piano nerds out there, I know that technically the frequency of the waves is what gives you the pitch on piano, but for our purposes, the amplitude, which is how big the wave is going to be measured on how low, right, or how high it goes, right? And then frequency is just going to be how quickly I can zoom my hand over these piano keys. First, let's start with being awake, which is, here's what I'm going to say it sounds like. So it's very low frequency, so it doesn't go the whole range, but it's also very fast, so it's going up and down very quickly. Now let's get into the first phase of the sleeping process, which scientists have cleverly named phase 1. So this rhythm that you find in the brain is called the alpha rhythm, unlike the beta rhythm, and it begins when you close your eyes and begin to relax. Now, what happens with your brain waves? Well, you still have low amplitude, so the waves aren't very high, but now we also get a lower and more inconsistent frequency that looks something like this, right? So the waves are small and they're not very frequent. But as you'll see, as you're here, this phase also includes what are known as vertex spikes. These are just spikes in the brainwave pattern that have a much higher amplitude than the rest of the wave. In terms of frequency again, exactly how much? About 8 to 12 cycles. Speed lasts for several minutes. That's how long the phase lasts. And it includes other side effects such as your heart rate slows down and your muscles begin to relax. You can think of this phase exactly as you would about the when you first start to fall asleep, right? You lie down, you close your eyes, start to de-stress, you relax your body, and you try to fall asleep. And that's exactly what this first phase will be like. Switch to piano cam. So phase 1, similar in amplitude to being awake. It's kind of the same area, but it's much slower. So the frequency is much slower. It's going up and down slowly. And then phase 2 also has these amplitude spikes that they're called, or vertex spikes as they're referred to. And so it goes all the way up and down. Remember, trying to be slow the whole time. So low frequency,
There's occasional spikes, but besides that, right in the middle, nothing too crazy.
Now, phase 2 of the sleep cycle isn't actually that much different than phase 1. There will just be a few small changes. The first of these changes is that while you're asleep, it'll still be low amplitude and low frequency. However, there are now these bursts of really frequent waves, and then also a couple really low dipping frequencies. Now, what are these? These are what are called sleep spindles. Sleep spindles. And these here they call K complexes. These here are just characteristics of the phase 2 sleep cycle, and this is how you know that you've entered phase 2. Is when you begin to see these sleep spindles, which are really fast bursts of waves, and also these K complexes, which are really negative measurements that you'll suddenly find out of nowhere. Now, these sleep spindles, they're about a little bit faster, 12 to 14 hertz, or 12 to 14 cycles per second. But still not that much faster than the alpha rhythm.
Phase 2 on piano is going to sound fairly similar to phase 1. Again, low amplitude, low frequency, so slowly going up and down. Not a lot of high or low notes. But now we also have the inclusion in phase 2 sleep spindles. These are sudden bursts of speed in your sleeping pattern. So these frequencies go up a little bit higher. They also include now what we have are K complexes, which is when our sudden, very negative spikes in the amplitude. So it's kind of the opposite of the spikes that we had in phase 1. There's sudden negative dips that we have.
Now, very surprisingly, phase 2 of the sleep cycle ends up leading us to phase 3 of the sleep cycle. Now, this sleep cycle, besides just being phase 3, is also known as slow wave sleep. And this because it's in this cycle that we see something new, these delta waves. Now, delta waves are for the first time high amplitude waves with also very low frequency. How low? These waves cycle about once per second, which is much slower than even our slowest that we've seen so far, the 8 to 10 cycles. Here's kind of what it looks like here. As I mentioned, it's just going to be high amplitude, but also low frequency. So these long, drawn-out waves. This cycle lasts for about an hour, and during this hour, it may occasionally revert back to phase 2 before it moves on to our final and fourth phase, which is what we'll be discussing right now, after this short piano break.
So, who would have guessed, after phase 2 comes phase 3, and this is probably the most unique out of all the different phases in terms of both amplitude and frequency. It has a very high amplitude, so a very high range on the piano, but then it also has a very low frequency, which means the waves are going to be very slow. And then remember, this is referred to as slow wave sleep. Starting at the bottom, slowly moving our way up all the way back, and all the way down again. Remember, this is when you're in, at this point, pretty deep sleep. All the way up, all the way down, very slow.
Now, finally, we have everyone's favorite sleep cycle, REM sleep, the one you most likely have already heard about. Now, REM sleep gets its name from here, rapid eye movement. Rapid eye movement. During this time, your eyes, rather than being still as they were in previous phases, they rapidly dart around. The other thing that can happen during this phase is you actually get total loss of muscle tone. So except for your eyes, which are moving around like crazy, the rest of your body goes completely limp. As we learned in the EEG lab, normally your muscles have some kind of tonality. They're slightly tense to do something, but during REM sleep, you lose all of that. The other really interesting two characteristics about REM sleep is that they actually resemble, in your brain, the activity resembles what it's like to be awake. So you once again have these low amplitude waves, but also with a high frequency. Very similar, about 15 to 20 cycles, similar as to when you're awake. So once again here, these cycles are low amplitude, but high frequency. So there's a lot of them in a short amount of time.
And now, reaching our final piano segment, as I'm sure some of your ears are very grateful to hear, we will be looking at REM sleep. So REM sleep is almost identical to being awake. Again, we have a very high frequency, so very quick up and down piano, but we've also have as well low amplitude. So again, very confined, not huge waves. It sounds something like this. Very quick, not very high. Again, very identical to being awake. That's all I have for you on the EEG measurements of the different phases of the sleep cycle and what they look like and how they act. The rest of this chapter deals with other questions pertaining to sleep, such as what are dreams and when do they occur during this cycle? What does sleep do for you and your body? And what different parts of the brain facilitate sleeping? If one can answer to these questions, they'll be answered in the rest of this chapter and by other tutorials by Team Axon. Thank you. Sorry that my face is all dark. I can't do anything about it.